The Earth is constantly changing. And while we usually think of this in terms of things like erosion and tectonic plate movement, the truth is that the Earth can change in an instant. Just ask anyone who was around when Mount St. Helens erupted in 1980, or the people of Pompeii who were wiped out by Mount Vesuvius in 79 AD. But these are small fry compared to some of the threats we face from our planet, such as supervolcanoes, which could spell disaster for us all. Hi, it's me, and welcome to Life Noggin. Today we are going to talk about supervolcanoes, the silent threat we must face. First, let's take a look at what exactly a supervolcano is. It's not actually a size that matters, but rather the explosiveness of the volcano. According to the Smithsonian Institution's Global Volcanism program, supervolcanoes have an explosivity rating of 8, which is the second highest rating possible. A rating of 8 means that the magma chamber below the volcano has emptied during an eruption. The empty chamber forms a caldera, which is a large lake-like depression. When this happens with a volume of material ejected over 1,000 cubic kilometers or 240 cubic miles, it becomes a supervolcanic eruption. So how big is that? Well, the most recent supervolcanic eruption was in 1815 when Mount Tambora in Indonesia ejected over 160 cubic miles of material during its eruption. This was the most violent eruption in recorded history. It had a volcanic explosivity index, or VEI, of 7. To put that into perspective, the VEI is scaled from 0 to 8. If a volcano has a VEI of 3 or less, it's considered non-explosive. A VEI of 4 or 5 is considered a minor or moderate eruption, and a VEI of 6 or more is considered a major eruption. So basically, Mount Tambora almost made it to the top of the scale. The VEI also describes the height of the eruption cloud. For Mount Tambora, it reached 22 miles into the air. In comparison, the 1980 eruption of Mount St. Helens reached only 12 miles into the air and had a VEI of 5. In order for an eruption to be classified as super, the amount of ash and rock must fill the magma chamber and the surrounding area so that there is no room left for magma. Eruptions that don't meet this criteria are called subplinian eruptions. These eruptions are still very violent and are capable of ejecting large volumes of material, but they don't quite make it to the 8 rating. As you may have noticed, I keep mentioning ash and rock being ejected during these eruptions. That's because, unlike many people's assumptions that supervolcano eruptions are filled with lava, that's just not the case. The word lava refers to molten rock that makes up the outer layer of the Earth's rocky mantle. When lava erupts from a volcano, it's called effusive eruption. Effusive eruptions can form lava lakes, rivers, and fields, and are often the result of low silica magma. Lava flows can be dangerous, but they're not as explosive as ash eruptions. Ash eruptions, on the other hand, happen when magma that contains more silica rapidly expands in volume upon contact with air or water. The expansion causes a violent explosion that ejects material miles into the atmosphere. But what makes these eruptions so dangerous? Why should you care? After all, if you live far away from a supervolcano, you likely don't feel any risk. Well, let's first talk about the immediate effects. During the eruption, pyroclastic flows, falling volcanic matter, and powerful shock waves would destroy everything in their path. Depending on the location, lahars or volcanic mudflows might occur. Lahars can travel at high speeds down river valleys and can carry huge boulders along with them. They are incredibly destructive. However, perhaps the most dangerous effect of a supervolcanic eruption would be the atmospheric injection of fine ash. This ash can spread over vast areas in a matter of days, burying entire cities in thick layers of debris. If the eruption is large enough, the ash and gas cloud can block sunlight and disrupt global weather patterns. When Mount Tambora erupted, the massive ejection of gas and ash caused temperatures across the northern hemisphere to fall 3 to 5 degrees Celsius or 5 to 9 degrees Fahrenheit below normal for several years. In 1816, the year following Tambora's eruption, it was known as the year without a summer. Crops failed, and hundreds of thousands of people died from starvation. Although Tambora's eruption was only a VEI of 7, A full-on supervolcanic eruption could cause even more damage. It might help to know where these supervolcanoes are located, so you can mentally prepare yourself. There are 12 known supervolcanoes around the world. The largest is located in the Lake Toba caldera in Indonesia. The eruption here is estimated to have occurred between 71,000 and 74,000 years ago. About 2,800 cubic miles of material was ejected during this time, and it is considered the largest known eruption in the history of our planet. Other supervolcanoes include Laguna del Sol in Nicaragua, Mount Mazama in Oregon, the Taupo volcanic zone in New Zealand, Ira caldera in Japan, Mount Vesuvius in Italy, and Yellowstone in the United States. Speaking of Yellowstone, this is probably the supervolcano that most Americans are familiar with. Located in the northwest corner of Wyoming, Yellowstone is actually a supervolcano complex. This means that it consists of 3 separate calderas that all sit above a larger magma chamber. The complex is roughly 43 by 28 miles and is home to 2 of the largest hotbed spots in the lower 48 states. As you can imagine, it is a popular tourist destination with millions of visitors each year. But it's also considered one of the most dangerous supervolcanoes in the world. Yellowstone lies along the convergent boundary of the Pacific and North American tectonic plates. The Pacific plate is moving underneath the North American plate and melting as it goes deeper into the earth. The magma then rises up through the weaker rock and forms a magma chamber approximately 6 miles beneath the surface. Occasionally, portions of the overlying rock melt and become part of the magma chamber. The pressure from the magma chamber causes the overlying rock to bulge upward. When the weight of the rock exceeds the pressure of the magma, the rock collapses, forming a caldera. This process has formed 3 calderas within the Yellowstone supervolcano complex. The oldest is the Lewis caldera, followed by the Mesa Falls caldera, and the youngest is the most well-known Yellowstone caldera. Yellowstone has been the site of multiple eruptions throughout history. In fact, the present-day Yellowstone Lake sits in the crater of the most recent eruption. Most of Yellowstone's activity has been restricted to the Yellowstone caldera. From 12,000 to 14,000 years ago, a series of eruptions took place in what scientists call the Lava Creek eruption. The total volume of material ejected during the Lava Creek eruptions was about 2,400 cubic miles. That's enough to cover all of Washington, D.C., under 12 feet of ash. These eruptions were so powerful that they sent ash as far away as Mexico and left behind a layer of ash at the bottom of today's Yellowstone Lake. And while the thoughts of tens of thousands of people being buried alive under ash is scary, others focus on the earthquake that would inevitably come before or after the eruption. Some reports say that earthquakes in the magnitude of 7 or higher will strike before the next eruption. The thing is, Yellowstone does experience regular earthquakes. In fact, between 1850 and 1985, there were 1,500 earthquakes that were large enough to be felt. Between 1985 and 2019, that number jumped to over 17,000 earthquakes, and in the first half of 2021 alone, there were 1,000 earthquakes. These quakes range from very minor rumblings to ones that shake homes and rattle windows. But none of these earthquakes have led to an eruption. Scientists closely monitor Yellowstone for earthquake swarms like this, but they haven't found a correlation between earthquake frequency and volcanic activity. Plus, if an earthquake swarm did precede an eruption, people would have plenty of warning. After all, the ground wouldn't suddenly open up. Instead, there would be visible signs that something was amiss. The ground would swell, steam and gases would be released, and small tremors would occur. All of this would alert the public that something was wrong. At least 24 hours of warning would be given before the actual eruption. Now, whether or not people would follow the evacuation orders is a whole other story. But there would be enough time to get out of the danger zone, unlike the ancient residents of Pompeii, who had no idea that Mount Vesuvius was about to erupt. They lost their lives because they didn't have access to modern technology that we have now. Speaking of warnings, Scientists are able to monitor volcanoes all around the world and predict their behavior by looking for subtle changes in their appearance. GPS sensors are used to measure ground deformation, seismometers detect earthquakes, and some volcanoes even have instruments inside of them to monitor pressure, temperature, and gas emissions. This allows scientists to see what's happening beneath the surface and gives us early warning signs that an eruption is imminent. So rest easy, knowing that if a supervolcano were to erupt, you'd likely have a lot of warning before it happened. And that's 1 minute. See you next